Hello, everybody, and welcome to today's webinar. This is webinar 3 in our Rapid Soil Regeneration webinar series. And today, the topic is going to be around Meet the Soil Regen Pros. So you're going to have a chance to be able to interact with some of us that are out there actually doing some consultancy work and bio-complete composting and all kinds of good things like that. So if you go next slide. Let's go through our topics for the day. So we're first going to start off with an introduction to today's panelists. So we'll spend about a half hour introducing everybody, and the panelists can give you an opportunity to talk about themselves, their journey, and their business. And then we'll talk about the Soil Food Web training program, and this is going to be also around the Launch Your Lab Plus offer. And so there'll be a short video kind of describing the school and the different training programs that are available. And then we'll have a Q&A session. So I'll talk to you in about a second about how to actually put your questions in for us to be able to review. And again, these are questions that you may want to be able to ask the panel, our experiences and things like that. And then we'll have a short poll just asking you folks a little bit about where you're coming from as far as why you're interested in this particular space. And then we have 2 animations that we're going to go through. The first animation is about a 6-minute video that's going to go through what is the Soil Food Web and to kind of lay out the basics of what constitutes making up the Soil Food Web. And then we'll have a Q&A session following that. And then we'll move into the animation on weed suppression. And this will be about another 5-minute animation. And then we'll have another Q&A session for about 30 minutes following that as well. And so we expect today's webinar to take about 120 minutes, so roughly about 2 hours. All right, you can go to the next slide. So a couple things here are webinar rules of engagement. So all the guests will be in muted mode for the duration of the webinar. We have usually quite a few folks that are attending, so we want to make sure that we have good audio quality, and so we'll keep everybody muted. And then we also have 2 interfaces for you on your website. The first one is going to be the green box. And in the green box, you can go ahead and post all of the questions that you want to be able to ask of us, the panelists. And if we don't happen to get to your question, which is really common because we have quite a few questions and we were only able to select a few of them to be able to review, we'll email you a response within 72 hours following this webinar. And then we also have a blue box, and this is a live chat. So you can chat with other attendees, and sometimes there's a good flow of conversation that's happening in the blue chat. Now, just remember, if you have a question that you want to get answered, though, make sure you post it into the green box. And if you have any, further need to look at instructions, there's an instructions button on the screen, and you can get more information about the tools. So, Alex, if you go to the next slide. And here's just a screenshot of what I just talked about. So there is the green box right in the middle of the screen, submit a question for the panel. And then on the right-hand side is the blue box where you're going to have your ability to post that live chat. We also have in here where we're going to have polls. And so there's a little purple button on the right-hand side. If you click on that, that will bring you to the active poll that we'll be reviewing. Okay, next slide, please. All right, so let's see, I just have to catch up here. Could be my internet. There we go. So in today's panelists, we have Dr. Elaine Ingham. For the reason why most of you here to attend this webinar is to be able to hear from Elaine. So she'll go through and give a brief introduction about herself. And then we have Renald Flores, who owns Flores and System. He's a soil food web consultant in Europe. And then we have Miles Sorrell, who is also a soil food web consultant. His business is Terraforma, and that's out of Colorado. And then we have Keisha Wheeler and Casey Ernst, who have Catalyst BioAmendments, which is a commercial compost producer. And then myself, I own a company called Sprouting Soil, and I'm also a soil food web consultant, and I'm based out of California as well. So we'll hear from everybody here a little bit more in depth. In fact, if you want to jump to the next slide, Elaine, I'm going to hand this over to you so you can do an introduction.
Okay, thank you very much. So I've been working with the Soil Food Web for a long time, like about the last time I counted it up was about 45 years. When I first started working on soil organisms, most of the soil scientists at Colorado State University, for example, and when I went to large groups of people meeting together. So like the American Society for Microbiology. People were always very negative about the usefulness of what I was working on, trying to understand the role and function of microorganisms in the soil, because of course their attitude was soil organisms weren't important. They didn't do anything. So I did a poll of all the soil scientists on the Colorado State University campus when I started my PhD, and that was their attitude: is you shouldn't do a PhD on any soil organisms because they're really not important. They don't do anything for plants. Luckily, we've been able to do the research, and we've been able to show that these organisms are very much important. Kind of as the understanding about gut microbiomes have come along, so has soil biology understanding. So we understand the soil microbiome every bit as important as the gut microflora. In fact, you can't maintain your gut flora if you don't have good biology in your soil. And so when you're eating foods from the grocery store that are raised in basically sterile dirt, you can understand why we have a lot of the gut microflora or the gut biome problems that we do have. So I always work with on trying to understand the bacteria. What are they doing? What do we have good guy bacteria or bad guy bacteria? Are they, which one is predominant? And yes, I'm just as broad in my characterization of soil as good guy, bad guy, because really we want to know if the microorganisms, if the bacteria, the fungi, the protozoa, the nematodes, the microarthropods, the earthworms, the enchytraeids, the spiders, all of the things that should be in soil. We want to know if it's the beneficial organisms or whether it's the disease-causing organisms that we are really dealing with. How do we convert dirt, which has just disease-causing bacteria for the most part, present, no fungi, no protozoa, no nematodes, microarthropod, none of the rest of that, present in that, well, it's dirt. It's not soil. The definition of a good, healthy soil requires the mineral component. And yes, most soils people will recognize that sand, silt, and clay are important, but that's not the end all and be all of what soil actually is. You have to have the organic matter in that soil, which is the food to grow the microorganisms that you have to have in that soil. So all three of those components must be present in order for you to talk about soil. Dirt is where you don't have all of those organisms. You're lacking all of the processes and all of the benefits that you can get from this soil food web. And if you take the foundation courses, we talk at some length about the 7 overarching principles that biology can only be, it is the only thing that allows those functions to actually occur. Now, we want to have nutrient cycling. We want to have nutrient retention in the soil. We want to build structures so we can hold on to the water so you don't have to irrigate all summer long. We want to have disease suppression that can only be brought about where it's a continuous, constant suppression of the diseases and the problem organisms by maintaining oxygen, by maintaining the right level of water. All of those things controlled by the soil food web. And so you need to get these organisms back into the soil. If you want to sequester carbon, you have to have these organisms in the soil to do that work of decomposing the organic matter and storing the carbon in their bodies, in the soil, in active growing sets of microorganisms. So all of these benefits are only because you have the biology in the soil. And the things that promote the beneficials, of course, are aerobic conditions in the soil, where you have a good flow of oxygen into the soil and maintain the habitat for your microorganisms to be able to grow, the beneficial organisms to be able to grow. So that's what we try to get people to understand, is the roles and functions of all these organisms in the soil. And so you can be able to grow crops without having to use soluble inorganic fertilizers. You don't need to use pesticides. You don't need those fungicides. You don't need the bactericides or the nematicides or the protozoicides or anything else asides, because all of those acidal compounds kill way more beneficial organisms than that compound kills of the disease-causing organisms. So we don't want to be using those things. We don't want to be using inorganic fertilizers, because every inorganic fertilizer, soluble inorganic fertilizer, is a salt. And it's basically going to be taking water away from your microorganisms and killing them. You know, think of you, if we dumped you into a vat of inorganic fertilizer, all the water in your body would be pulled out of your body, and you would die of dehydration. So salts, well, think of salts in the ocean. Why do you not drink salt water? Because it's going to remove the water from your body and cause you to die. So salts are not a good thing to be putting on our soils. Lime, gypsum, sulfur, the sulfur fertilizers, the nitrogen fertilizers, phosphate fertilizers, potassium fertilizers, they're all salts. And you're killing the very organisms that would otherwise allow you to not have to use those inorganic fertilizers. There is no soil on this planet that lacks the nutrients to grow plants. It's just that those nutrients are in a plant unavailable form. And you must have the biology, the bacteria and the fungi and the protozoa and the nematodes and the microarthropods and the earthworms and et cetera, et cetera, et cetera. They have to be there to convert those not plant available nutrients into a plant available form. So we're hoping that you will have interest in taking the foundation courses, and then perhaps going on to become part of the Soil Food Web family and get this information out to everybody on the planet, because we have to do this. We have to stop destroying our soil and turning it into the dirt. We've got to convert dirt back into soil. So come and find out how you do that. Thanks.
All right, thanks, Elaine. And they'll definitely find out here in just a second when we watch that video about how they can sign up for the classes and all that kind of good stuff. So, all right, next slide, please. I think, Renald, you are on board. So, Renald, if you want to take it away and just give Alex direction when you want to move on to your next slide.
Yes, sure. Well, so the first slide should be about, yeah,
Alex, I'm not sure if you're sharing. It's not coming across. I think we're back into our Zoom panel page. There we go. All right.
Yeah. So, yeah, my name is Renald Flores, and so my company name is called Fluorescent System. And what I do, I support farmers to do that transition from a conventional model to a soil food web-based model. Next slide, please. I have a weird screen of the...
Yeah, it looks like, Alex, you're not in full screen mode. We can see a lot of your desktop, just to let you know.
Yeah, so continuing on, I'm based in Geneva, Switzerland, and mostly operate, here we go, and mostly operate in Europe. This is where I got my first clients, farmers. Next slide, please. And so why providing farmers solutions to transition? Because basically these guys have just learned the conventional way, and even though they wished to transition, they don't know how to do, and even more when we talk about the correlation between soil food web and the result as yield and carbon sequestration and water holding capacity, just talking about a few. Next slide, please. Going ahead on clients, my main my main client is in Latvia. It's a really, I mean, for Europe, it's a large scale farming. Farm is 5,000 acres. And the trial I'm doing with them under this transition capacitation or skill transfer is on 60 hectares. I've also started to work in the French region of Champagne. My farmer is using wine grapes leftovers to produce beautiful compost. I helped and to produce beautiful compost and then deploy a soil regeneration again program for him to understand the correlation. And this is pretty much the same in Austria. Next slide, please. A little more than 5 years ago, I came across the Dr. Elaine Ingham soil food web course, and for me it has been life-changing. Really has given me such a depth in understanding how this whole growing vegetable crops functions. And so along that, of course, learning about compost and then the compost tea and the microscope, etc., that would give me, that would open me the door into large scale, medium scale agriculture, and even permaculture. I mean, if we want to do it small scale, it's absolutely fitting the purpose. So yeah, after I finished, well, roughly in 2016, then I went ahead and just had my first little trial in the vegetable market in Sweden, and then on, Latvia, France, and Austria. Next slide, please.
I think that was it.
Oops.
Yeah.
That was it. All right.
Yeah.
Thank
Anything
you.
else you want to add before we close, Renald?
Yeah, I'm happy, yeah.
Okay, great. Miles, I think you're up next. So just give Alex an indication when you want to move to the next slide.
Yeah, no problem. Hi, everybody. My name is Miles Sorrell. I'm the Chief Science Officer with Terraforma. Go ahead and go to the next slide here. And you can go ahead and you should be able to click to pop up the next box here as well. What we do at Terraforma is to enhance biological functionality of soil, as Elaine had indicated. That means that we want to rebuild the soil food web, pull farmers off of synthetic fertilizer usage, pull them away from chemical usage, and build soil organic matter and a sustainable growing system. However, we really want to focus on doing this in a way, which I think we all hold this sentiment, of increasing the sustainability while also increasing farmer profitability. We see this as the larger thoroughfare to accessing the broader market of agriculture in the United States and abroad. So go ahead and next slide. You have to double click it. So we work all over the world. We are headquartered in California. I'm currently located in Colorado, but we've worked in multiple different tropical and subtropical climates, ranging from India to Argentina and Ecuador. We have a number of different crops that we've worked in, ranging from cannabis to tea gardens, turmeric, cotton, a lot of banana work that we've done. We've also done some work in Africa, but we haven't been able to really get there in a meaningful way because of COVID and certain government regulations and things that have been happening within those countries that make it a bit difficult. But it's because of this diversity of environments and places we've had to implement these different projects. We have to be very flexible with our approach and understanding these different climate zones and how to implement proper practices and how we're going to build out different biological solutions for these different regions. So it's been very helpful for us to be able to take this broad picture and tie all of that experience together when we approach a new project with an individual. We tend to work with medium to large size growers, typically monocropping growers that we help to integrate some broader diversity in terms of their cropping choices or associative plants, and help to change their practices a bit and implement a more biological approach to growing. Okay, next slide. Our process that we tend to implement is something that is similar to what you'll see in the soil food web. We go through an assessment phase, an implementation planning phase, and then a monitoring phase. So this involves essentially getting to know the farmer, usually getting on site, understanding a bit better the situation, the equipment they have on hand, and then planning out our full implementation plan that we're going to be able to go from point A to point B with these farmers. So starting from where they are today to how we implement different practices, different SMPs, or sustainable management practices and biological solutions to regrow the soil microbiome to the state that we'd like to see. And then we have an ongoing monitoring and involvement approach where we can continue to track that progress through time, continue to aid the farmer. We don't want to just let the farmer run off on their own and have to struggle through trying to make things work. Next slide. So what this has culminated in for us is building off of the knowledge we've gained from the soil food web, building on top of those analytics that you learn to implement and learn to understand in the soil food web, and kind of taking that and adding on to that to get a broader understanding for our own purposes of like the genetic component of soil, and then building out our own systems and equipment to help us service and create these solutions for farmers so that we can implement the optimal options and make it as easy as possible for them to receive these types of biological solutions and get them into the fields in the best way possible. And the next slide, I think this might be my last one though.
I think that was your last one, yeah. Great, thanks Miles. Okay, Keisha and Casey, Catalyst BioAmendments. So go ahead again, just give Alex an indication when you want to move to the next slide.
Hey guys, I'm Casey.
I'm Keisha.
We own Catalyst BioAmendments. It's a biologically focused compost company in Northern California. And I guess our journey into all this kind of started, we lived in Ecuador for the better part of 10 years, and we were super into permaculture and just kind of saw that there was a little bit missing to that system, that we just didn't quite fully understand everything that was going on and underneath the ground. And so that's how we found Elaine, and we kind of dove headfirst into that. And next slide. After getting involved in the classes and going through the consultancy training, we realized that kind of the missing link to all of this is having a good biological product to actually use to regenerate soil with. And so we decided, like, right out the gate, just let's go start a compost company. And that's what we did. Next slide. Next slide.
Take some time for the
Stuck in the interwebs.
Now you can see why we chose this piece of property on the left. It's super degraded land. You can see where our lot is. We picked that area that sheep had overgrazed, and there was literally nothing growing there. So we thought that's a prime place to make some compost.
Exactly. Alex, I'm not sure if you're having issues, technical issues, moving to the next slide. There we go. All right.
So since we started, you can see here on the left, that's the smaller turner that we had, the Mighty Mike. It's an inexpensive pull behind turner, and we could only fit those 3 windrows on our lot at the time. And we just had such a hard time keeping up with demand. We were always sold out. We were doing everything by hand with pitchforks and just completely exhausting ourselves. You can see on the right, we upgraded to the Bacchus. It's a much larger turner. We can fit, double, triple the amount of compost on that same teeny area. Go ahead and skip to the next one, Alex. And so sourcing ingredients has been the most difficult thing. We have a really expensive product, and we've realized that it is so difficult to source free ingredients that are chemical free. We've realized at this point that now that we're buying, 100 yards of wood chips at a time and, 1,000 bales of hay to create these giant windrows, we have to pay for everything that we get in just to make sure that it is a quality, clean product. So it's been a real adventure sourcing materials and scaling up. Next slide, please.
But yeah, we've been able to, move forward. We're finally getting our products into stores, and I don't know. It's been a fun journey, kind of diving into these classes and just like figuring out the food web and figuring out like how we can start implementing this out into growing systems and agriculture, and just seeing that benefit that we can get when we actually focus on the microbes in these growing systems.
Before we move, I'm just going to make a comment on this photo. Those bags never worked. As we move through trying something new, we've been trying to develop a way to package our product in a bag and put it on a shelf so it's actually stable and the life continues to live in the bag throughout, the weeks that it's sitting there. This one port hole system was never enough oxygen for the bag, so that was a big flaw on our part. So now we're, setting up some mushroom grow trials just for fun to use the rest of that plastic so it does not go to the dump. But I promise on the next webinar we'll get real pictures of our packaging in so you guys can see what we developed. Next slide. And then we had a fire last year, and it took out a lot of our machines in our above lot, and it really pushed us to open up some new space. So the photo you're seeing here is 4 times the area we had before. We have a massive amount of space to compost now. We have the upper lot, we have the lower lot. Everything is finally settled, and including the lot, the soil is nice and hard, and we're gonna have a nice winter. Working on this new beautiful pad. So sometimes disaster just leads you to a whole new reality.
For sure.
The compost covers on the right are compost covers that we had to develop and have made. The black composting covers that were available to us through, Compost Tech or these companies in the States, they get too hot in the California sun, and we find that they just dry out the top, 4 inches of our compost fairly quickly, and all the microorganisms that were there are insisting and just kind of going dormant. So those are our beautiful shiny new white covers and our beautiful shiny new lot.
I think that's it.
Yeah, I think that's our last slide.
Great. Thanks, Keisha and Casey. All right. It's my turn. So I am Brian Vang. I have a company called Sprouting Soil. Alex, you can go to the next slide. And there we go. So my wife and I, Shelby, we created Sprouting Soil about 5 years ago. And really, we had multiple goals. We wanted to be able to inform and educate and assist the farming community in making this transition from conventional organic to farming with biology. And even though farmers have been kind of our main goal, we still have a lot of clients that fit into the residential world, landscaping communities, and so forth. And so really, anything that has a growing system is something that we advise on. So a few things about my wife and I. So I am a soil food web advisor, so I've gone through the training with Elaine. Keisha and Casey, who you just saw, we're all members of the Sierra Soil Biology Association. So we've created a nonprofit to do outreach and help farmers in our local area make that transition. I currently have a 5-acre homestead in Armour, California that we've been working on for almost 20 years, and it's been quite a journey. I started our homestead in a very conventional sense. That's what I knew when I was growing up. I grew up on a homestead, but I had a rototiller. I had all the different herbicides, all the sides that Elaine talked about before, and it was trying to manage it in that sense. And I just got to a point where I was looking at all the labels on the chemicals I was putting into my system and going, I'm eating this. This is not good. And so I made the change originally into permaculture to start with, kind of like was mentioned before, seeing results and seeing it working, but I didn't understand a lot of the whys, and that's really when it came around to seeing Elaine, and that really kind of connected a whole bunch of dots for me as far as, oh, this is how the soil food web actually works, and why the way I've designed some of these systems are working so good versus the way I used to do before and things like that. I also did come from a career in technology, so I was in the high-tech world for almost 2 decades, And it was a great job. I had a lot of passion. I'm a computer nerd through and through, but homesteading and growing systems was more of a passion. And so my wife and I decided to make a switch. We said, all right, we're going to leave the high-tech world and we're going to open up our own soil biology consulting business. And we're very passionate about healthy living. So we do a lot of on-farm, making ferments and preserving food and growing food for ourselves, our family, and our friends. Next slide, please. So as far as sprouting soil, now a lot of consultants can either tailor their business to a very specific industry. Some of our consultants come from some of those industries, like wine growing or banana plantations and things like that. But we took a much more broad approach. We said that we want to be able to service many different types of agricultural and then also residential systems. So in that, we need to be kind of a fully functional or very rounded out, have a business focus in that sense. So we do soil assessment lab services. We also have biology consulting. And then the assortment of remediation services. So that's brewing compost extracts and teas, doing the spraying. I have a spray rig, and then also doing deep root zone injections and things like that. So actually going out there and doing the work. And for some of my clients, that works great, especially my smaller clients. But when we get to any kind of scale of agriculture, normally what we'll do is we'll go ahead and specify those systems for that farmer. And we'll get that system up and running so the farmer can use that equipment on a very regular basis. And then also doing different research and studies. So I've been hired by a number of companies to do some additional research on their products and how it impacts the soil biology and so forth. And then something that's near and dear to me as well is doing education. I think part of what we do is helping make this transformation is helping farmers do this work and giving them guidance. But the same aspect, most of them are coming from a standpoint of a very agrochemical, and it could be generational in that kind of world and that technology. And so we find that we need to actually provide quite a bit of education to the farmers and their management teams and their workers about how to become a microbe farmer, how to actually work with the soil biology. Next slide, please. And I get this question all the time. A lot of people write me and say, hey, look, you're a consultant, you're out doing this work, what is it like to be a consultant? And I have to say that every day tends to be different. There's a new sets of challenges or questions or things that I need to research. I mean, there are definitely some things that can repeat and be a little bit repetitive, but I haven't really had many days that seem to be the same. And in a day in the life, I could be working with a microscope. So I do a lot of assessments, both qualitative and quantitative assessments. Writing reports. It's very important to be able to communicate well to your clients all the data that you've been collecting and everything that you've been observing, and then be able to summarize that in a way that's very digestible by your clients. So writing reports is definitely a very big skill set that we have to do. And then calls with clients, meetings, again, this is part of the educational process, doing the analysis and things like that. Going on site. I do have clients that are all over the United States. So some clients I've never been on site with before, and other clients I've flown out and worked with them on their operation. And then just doing research. I will a lot of times get questions from clients to say, hey, I got this product, or my neighbor's been using this. What's the impact to the microbiology and things like that. So you have to go out and find, potentially what those impacts could be, both either positive or negative. And then running your own business, you have a lot of admin, invoicing, bookkeeping, things like that. So that's really kind of a day in the life as a consultant, at least from my operation. Okay, I think that concludes the introductions. And so now most of you should have a good idea about the panelists and some of our background and our history. And so get ready with your questions. But before we get to the Q&A session, we're going to run a small video here, about 5 minutes, talking about the Soil Food Web School and the different training opportunities that you have, and then also talk about the Launch Your Lab Plus offer. So Alex, if you want to go ahead and kick off the video.
Professionals. Many of our students don't have a background in agriculture at all, but are individuals who are really passionate about the planet and who are looking for a new career where they can make a big impact on how the soil and our waterways are being treated and on how the food we eat is being produced. So let's take a look at some of the career paths that can be followed by the students of the Soil Food Web School and the different programs that are available. Everyone starts here with the foundation courses, where they cover all the science and application methods behind the soil food web approach. This is a series of 63 online lectures, each followed by a quiz. You can log in at any time, watch a lecture as many times as you like, prepare your notes, and then take the multiple choice quiz. Each lecture is approximately 45 minutes in length, and we recommend that you dedicate around 150 hours to completing the foundation courses. You get to download all the lecture slides and the FC course manual. You also get access to the FC forum, where you can ask questions that Dr. Ingham and her team will answer for you. You can then elect to move directly to the consultant training program, which is where you put all the theory into practice under the guidance of one of our highly qualified mentors. In Stage 1, you'll be challenged to make biological compost and to master the microscope in the Certified Lab Tech program. In Stage 2, you'll use your compost to make liquid biological amendments, which are used for foliar applications or soil drench. And in Stage 3, you will be using your amendments to regenerate a small patch of land in the final project. At the end of the 3 stages, you will be certified as a soil food web consultant, so you can start working with farmers to help them transition away from using chemicals to working in harmony with nature. You will also be certified as a soil food web lab technician, which qualifies you to perform sample analysis for local farmers and growers. You'll be qualified to make biological soil amendments, including compost, extract, and teas that meet the minimum biological requirement for soil regeneration. Alternatively, you can elect to go from the foundation courses to the Certified Lab Tech program first. Here, you'll work one-on-one with your microscopy mentor to develop your skill to the required standard to become a certified soil food web lab tech. This is a good idea if you're not ready to jump right into the consultant training program right away, and if you want to start making connections with farmers and earning a little money first. By performing biological analyses for farmers, you can start to build valuable relationships with folks who may one day become your consultancy clients once you have graduated from the CTP. This is a great way to kickstart your new career as a soil food web professional. Some folks choose to stop at the Certified Lab Tech program, whereas others choose to go all the way with the Consultant Training program. The choice is yours.
We believe that restoring the microbial life to the Earth's soils is a big part of the picture when it comes to protecting the planet we live on. Soil erosion, ecosystem collapse, and even climate change have all been connected to the way we farm. So if you're ready to help the farmers in your region discover a better way of treating the earth while simultaneously increasing their profits, this could be for you. Remember, you don't need a background in biology or agriculture to be successful in this field. If you are interested in joining the soil revolution, this is a great time. With the Launch Your Lab Plus offer, you can register for the foundation courses for just $3,750 and save $1,250 off the regular price of $5,000 through July 22nd. You'll get access to the Certified Lab Tech program for free, saving $1,000. And you'll get the Introduction to Permaculture for free, saving $250. This is an 18-lecture course that covers a wide array of permaculture principles and themes, delivered by Graham Bell, Chair of Permaculture Scotland and longest-serving permaculture teacher in the UK with 31 years' experience teaching on 6 continents. Permaculture is a regenerative design approach that can be applied to just about anything, from water management, growing systems, dwellings, and much more. Remember, with the LYL Plus offer, you'll pay just $3,750 for the foundation courses, and you'll get the Certified Lab Tech program for free. And you'll also get the Introduction to Permaculture course absolutely free. That's a total bundle value of $6,250, for which you will only be paying $3,750, saving 40% off.
Today, we are making 50 exclusive coupons available with which you can save an additional $300 off the Launch Your Lab Plus offer. The coupon is available at the bottom of your screens now and is valid through midnight, July 22. Simply scroll to the bottom and click here to save a total of $2,800 off the amazing Launch Your Lab Plus Permaculture Bundle. Remember, there are only 50 coupons available, and with today's attendance expected to exceed 1,000 people, these coupons are likely to go fast.
Okay. Thank you, Alex, for running the video. And as we just saw at the end of the video, so there is a kind of time-sensitive coupon. There's the 50 coupons for an additional $300 off. And as the video just described, just go ahead and click down at the very bottom of the window, the screen that you're looking at now, and you should be able to apply that coupon. Or that coupon will get applied, actually, once you click on the button. Okay, all right, let's move into some Q&A. So there's a lot of questions that came in around marketing. So how do we market our services to farmers? So there's a question from Mark, there's a question from Barbara, and also a question from Sandra wrapped around this. And so panelists, what are ways that you were able to market your services, and how do you continue to market your services today? Anybody want to take a crack at that?
Yeah.
Go for it,
I can only share about my experience, and what has really worked with me is the the fact that I made a trial that is part of the certification, and I wrote a little scientific essay that I published, and well, I got Elaine to read it, and at that time her partner working with her, and so the feedback was good, so I published it. And then some people called me to introduce the topic. What is that thing of soil food web? How does that work? Because I used my trial as for showcasing, and so attended farmers meeting. At that time, it was a no-till gathering and meeting, talking with farmers. Some of them were eager to come on board and try, and that has been then a kind of a snowing ball that just grew up and enabling me to continue working. That's it.
Mm-hmm. Yeah. I just give a little personal anecdote for myself. So early on, when I was really just starting my business, I took the advice from Elaine, which was go out and talk to different growing groups. So find, the Master Gardeners, something that we have in the United States called the Master Gardeners Group. There are a lot of, local farmers guilds that could be an almond guild or a grape guild or, whatever it is. It's very specific to that kind of farming. And I just started calling all these different organizations saying, hey, look, I've been trained in this particular aspect of the soil food web. Is there an opportunity for me to go ahead and just give a presentation on soil biology and how it can help, in growing systems and a different way of doing things. And I got really positive response from a lot of those groups. So I actually give quite a few talks to different groups. And that was kind of the first initial way I was able to get clients into the system, at least into my system. And then also with my name getting put on the website was another big thing there too, because folks are looking for consultants can go to the website and then reach me. But I have to say lately, I haven't had to do much marketing at all, because really what's happening is I'm getting farmers that talk to other farmers, and they're like, well, why don't you just go talk to Brian? And so then I'm getting a lot of this referral business coming to me. In fact, it's such an amount that I can't take all the referrals that are coming. So I think it's really important early on in your business to do a lot of that different marketing, and I think education's a way to go. After a while, it seems to me that you just get a lot of referral business and a lot of business coming that way. So panelists, anybody else want to comment?
Yeah. We were really lucky when we started Catalyst. Just as we were finishing up our first windrows, we got to host Elaine for a workshop on site, a 5-day microscope intensive. And I would say 5 or 6 of the students in the class bought compost from us. They took a chance and took it home and got great results. And the first 1.5, 2 years of our business was all word of mouth. Just once somebody would use the compost, say it was fantastic, and then their friends would call. And we did a lot of Instagram work, a lot of chats online. But at this point, now that we have so much compost for sale, we've been holding these like microbe events. And so we get people together. You know, we realize if you haven't gone to the Soil Food Web School, you probably don't know how to make extracts or teas or really understand why you would need a product like ours. So that has been amazing. Just like reflecting what Brian says, just speaking in front of people and sharing the passion and the knowledge and excitement, it really generates a lot of interest really quickly.
Yeah, being an ambassador, for sure. Yeah. Miles?
Yeah, I would just add to that getting your first couple projects under your belt and having something to kind of stand on. So being able to take a couple farmers from a conventional setting and move them towards a system where they're making their own compost, or you're selling them compost, or they're implementing with that, and they've got their own system set up in place, and they're yielding some results from that, and they're satisfied with that product, is a really good way to get started. So, you know, as Brian kind of indicated, making some of those early connections, getting into there and like doing a smaller trial with these farmers that they can see the results themselves, and then scaling it up from there is typically a pretty good way to move forward for trying to acquire new clients.
Yeah. And another thing that's actually been very nice in the community of us is also, I call it kind of co-opetition, where there are going to be clients that aren't a good fit for what I'm doing, but there's another consultant that is. And so me saying, you know what, let me pass you on to this particular consultant, because they're either in the right geographical location or they have a lot of experience in that area. And I've had other clients forward to me from other consultants as well. So this whole, you know, finding what's right for you and then passing it on to people that are in the community, it's been another fantastic thing. And a lot of people get this, well, aren't you competitors? And I'd say that we are years, maybe decades away from us having massive saturation in this market where we're all going to be, you know, really competing for clients. I think there's so much potential. There's so much acreage that has to get transformed that we're in a much more cooperative mode, I think, and working together. And hopefully that maintains all the way through. I mean, it's that kind of, I think we all have that kind of mindset of we need to move this, not just for our own businesses, but also because it's the right thing to do. So.
And I think that's one of the things we see quite often is, you know, once you get the word out to the local community and, you know, going out to different grower groups, going out and giving talks at the co-ops, giving talks at whatever various places, you know, if there's a organic convention or there's the potato growers, a convention, you know, go and give a 15-minute, 20-minute, hour-long talk about what it is you do. Show some examples of what you did for the final project where you're supposed to convert dirt back into soil and look at all the benefit to the plants. And you therefore have data that you can show people that you know how this works. And then once you get a couple of clients under your belt, as you're saying, Brian, Miles, you know, Keisha, Casey, and Renald, you don't have to be advertising anymore. You're bringing enough in word of mouth. And actually the place you're at, Brian, is very similar to quite a few people who have gotten far enough along that they can't handle any more clients. And you've got to make a decision whether you want to pass those clients off to other consultants that are just starting out, or whether you want to hire another consultant, new consultant, and start forming a company. I myself really don't like the fact that I have to pay wages to somebody else. So Thank goodness the school takes care of all of that for me.
For sure. Part of the business admin part of it, we're like, oh, okay.
Yep, because I really like the
that's reality of
research.
it.
I like the research part of it way better than anything else. So we keep discovering new and improved ways of doing things. And we're about to add microarthropods to the soil food web structure that we've got. So ever increasing our knowledge base so that we can stay on the cutting edge for everyone.
Yeah, definitely. All right, well, that's a great question. Got another good question from Trisha, and Trisha asks, when soil is dead, is it possible to bring it back on a large scale? All right, who wants to tackle that one? I definitely have an opinion, but I want somebody else to go in front of me.
Yeah, I can take a first crack at that.
Sure, go for it.
Definitely possible. It's definitely possible to rejuvenate soils on a large scale. You just have to scale up the systems that you're using. So if you're used to working on a small scale land patch of land, or like a quarter acre or something like that, and you need to address 500 acres, you need to scale up how you're approaching that system. So integrating into the machines that are being used, integrating into a larger foliar spray system or extraction system, so you can create the product at scale to be able to inoculate soils, apply to all of the plant material there, be able to work alongside the farmer in a slightly more involved way where you can help to pass along better management practices for soil microbiology and work with them to establish those practices as well. So it's definitely possible, and we've done it on thousands of hectares at once, and it's not all too different than doing it small scale. It's just you have to keep a little bit more attention to costs and how that factors into an operation that's that large.
Yeah.
And I mean, oftentimes too, when you're going into these larger projects, these farmers already have equipment they apply stuff with, right? They're already putting out foliars and things like that. There's probably chemicals. So you usually are just figuring out how you're adapting their machinery to work with this system. So a lot of it is actually talking to the farmer they're the expert in growing the crop. You're the expert in getting those microbes out there. So you're kind of in this conjuncture with them and kind of learning how to just change their practices a little bit in order to focus on biology instead of, getting those chemicals out there.
Yeah. Yeah, that's when we're working with, especially with large scale clients, there's usually a lot of money that's on the line. They want to maintain production and all those kind of things. And I always, try to work with my farmers in the sense that it's, yes, we're applying biology, we're making some changes from chemical products to biological products, but much more than that, it's a review of their management practices. And I try to get them into a mindset of saying, let's look at all the things that you do and let's put them in 3 categories. Is what you're doing beneficial to soil microbiology? Is it neutral or is it harmful? And all the harmful ones become the high priorities for us to find alternate ways to change those management practices. Once we get the harmful ones out of the way, then we'll look at the neutrals, and we're trying to push everything into benefiting the soil microbiome. And with that as well, I always try to get my clients to do a trial, a small set of their operations, so that they can really internalize what the management practices changes need to be on a small scale, so that they can really start thinking about how to make those changes on a large scale. Some of my clients want to jump in with both feet, and that's fine. But a lot of them I recommend, hey, you have 1,000 acres, let's go take 30 acres and let's apply these new practices and look at your management practices on that small scale first. Renald, anything you want to add?
I can only confirm all you guys said. I would be repeating exactly the same things. That's true. Sure. I confirm.
Yeah. Great. Okay, so here's another question. This one's from John, and there's a couple of questions that are also related. Other people have asked in this, but how long does it take for microbes to repopulate after stopping the use of chemical additives? Who wants to take that one?
Well, as short as the first season. Sure. Elaine would confirm that, I'm sure, and all the other consultant too. Once you know how to use that microscope, recognize the microbes, etc., etc. I can talk about my experience, the trial that I'm doing. I'm comparing conventional with cover crops and soil food web style with cover crops, and both sides have the biology back as soon as the first year. Of course, the proportions of each are different, and the yields are different, of course. But that's, yes, a definite, clear yes. First year.
Right. Yeah, I think there's a huge it depends type of equation to this. As Renald said, I've had clients first year make massive transitions into biological and seen really good successes. Other clients, it's going to be probably a 5-year road for them to get to that spot. And a lot of that depends upon the quality of the soil that you were working with, you know, what kind of contamination do you have, and compaction issues and so forth. And then also, how quickly are they able to change their management practices? I have a client that, you know, we're on this process, but because of the way they harvest, they still need to spray glyphosate. And so we are looking at, well, how do we reduce the amount of harm because you're using these products to do this? And it's one of these things where we're taking 2 steps forward, maybe 1 step backwards, but that's something you have to negotiate out with your client. So it may take us 5 years to get to where we need to be with that particular client, just because of what they're comfortable with doing. So yeah, it could be really fast. It could take a little bit longer. And so there's a lot of it depends in there as well.
And that's
Anybody else
why
want to take it?
you want to work with your client. You know, what are their expectations? What are their fear points? What are they afraid? And you handle your client. There's got to be a little psychology there. And, you know, someday we'll have a class that people will be able to take on how to manage your clients with this kind of process. But as long as every year we're improving that biology in the soil, we are increasing the yield, we're increasing flavor, nutrients in the plant material. So things are always getting better. You know, it's like people always get afraid when you say, well, it's going to take 3 years. Well, but in the first year, there's already an improvement. In the second year, there's an additional improvement until you have actually reached the genetic potential of that crop to produce under your conditions. You're going to keep seeing those improvements as you improve the biology in the soil.
Exactly. And I think data is so important, you know, being able to take data from the microbial assessments, but also maybe plant sap analysis or tissue analysis, soil chemical analysis, all the things that farmers may already be used to, and showing that, yeah, what we're doing is actually making incremental steps forward in this process. And, you know, one of my clients, we were able to cut their nitrogen application in half first year. To them, it was like, wow, okay, this is huge. That means the microbes are already doing that nutrient cycling year 1, you know, taking up half of what I totally would typically put on my fields. And for that, my farmer was like happy. It's like, great, this is moving in the right direction. So
how much money
you know,
did they save per acre?
Exactly. Yeah. And that's a bottom line. Most farmers are going to get down to is saying, well, it's dollars and cents. And are you saving me money, or is this becoming more costly? And so having a good data to be able to help back up, hey, yeah, we're making it incremental improvements. Your crops are actually, you know, performing better, and you're actually saving money, is a big thing for farmers. They really start to say, okay, now I want to transition faster. I see where this is going. Let's really start to push this. So Keisha, Casey, Miles, anything you guys want to add?
No, I think you guys covered that pretty well.
Yeah. All right. Great. So this is a question that came from Betsy, and Betsy says, I do not have a degree in biology or environmental science. I'm concerned that it will be hard for me to get clients without a degree in a related field. Are most of the graduates in the related fields just adding to their knowledge? Once I go through the Soil Food Web program, what other degrees would you recommend I take or be taken seriously as a professional? All right, who wants to take that one?
I'll go with that one as an uneducated person. I have no degree in anything. I was a massage therapist. I'm a hands-on kind of learner. I never found any interest in going to traditional university. There's just so much that you have to do that isn't in line with your interests. And so it was such a turnoff for me always. But when we found Elaine's program, you get to dive deep into these subjects, and there's no need to do anything else. Like if you're not interested in English or I mean, you have to do math no matter what, unfortunately. But all these topics that you don't have to pay attention to. You can focus directly on the biology and the microbes and the microscope. And really, there's so many things to learn within just the school. You know, we focus on compost and consulting, but you could just dive deep into the microscope and just, you know, go hard on microbes. There's no need to have any sort of degree to understand what's going on here. Everything is broken down so simply. It's really easy to understand. The only thing is with the online courses, you have to realize it's online. So if you're a person who is, you know, you're learning in person, you're probably going to have to take notes and maybe rewatch the sessions a few times, because it does get a little bit deep when you're talking about the nitrogen cycle, or, you know, there's some classes that are particularly challenging. But I found that just by watching it a couple times, really taking notes and looking into it deeper, I was able to grasp it, you know, pretty simply. Casey did go to college, so he might have something to say about experience.
I don't know. Yeah, I think it's this stuff is broken down into, like, even when we're doing any of our talking, you know, it's like you're really trying to break this down into the simplest form you can. And most of the times, if you're dealing with clients, like, your farmer probably doesn't really care why the microbes are or how they're dissolving the rock to produce nutrient or anything like that. They just want to know how they're going to implement this. So as long as you have that knowledge in yourself, I don't see how having another degree in microbiology, it wouldn't hurt, but I don't think it's necessarily something that you're absolutely going to need.
It could actually focus you in a way where you would decide on a major. I mean, like, at this point, there's things that I'm like, wow, I'd really like to look deeper into that, but it's more out of interest than necessity.
Anybody else want to take a question on that?
I think that's about right. I also have a 4-year degree in the sciences, and that's helped in terms of understanding complexities within the classes and the concepts behind everything. But again, you don't have to have that. It's something that just is, if you have it, that's great. You'll get things a little quicker maybe. But you know, if you'd like to continue expanding your education, I think a lot of people that have come through the course have continued to learn and dig through white papers and try to, like, expand their presence and knowledge about soil health and general soil principles. So, you know, it's a good leaping off point. This is sort of like going to a college level course and getting a lot of this information and being able to take that information and build something out of it. So it doesn't stop at the end of the soil food web courses per se. And you certainly don't need to have that prerequisite knowledge to kind of understand things and dive into it.
And you don't have core humanities classes.
Exactly. Yeah. I don't.
So it's fine. You just call them.
Yeah, I have a degree in information systems management, right? So biology is my passion. So I think, you know, if you're a passionate person about this, you'll be able to pick this up, you know, very, very easily. And I also say, you know, the post education, I'm finding with my business, I am not stopping educating myself. I'm diving deeper into mycology. I'm diving deeper into nutrient cycling inside of a plant. And there is so much new research coming out that I want to know more about. So I feel like I spent a good chunk of my time actually educating myself on, you know, different tangents or pathways or, you know, corollary types of subjects. I don't think I'm ever going to stop doing that. I don't think I could, actually, to be honest with you.
And then you want to realize that once you're finished with the courses, once you have graduated and you have your certificate, which gets to hang on the wall, and you can always point to that as, yes, I've completed it. I have a good idea of what I'm doing. But we always have these webinars where we bring up new information, where we're talking about what's the latest, what's the cutting edge in these different aspects of biology, so that we're always increasing our knowledge. We're taking on new challenges. We're going to be growing plants in, you know, Southeast Asia. We work with people in India. We work with people in Australia and New Zealand, and you name it. So there's always more to know. And as long as you have that interest in learning more, we're going to be right here discussing things, working with our, you know, past students, so that we all stay on top of the new discoveries that are being made.
Exactly. Yep. Okay, I say we're going to stop questions Q&A for right now. If we're going to go ahead and do a quick poll, and then we're going to have an animation that we're going to look at. So Alex, if you want to reshare out. And so just let everybody know, we have a quick poll. So this is something we're asking for you. Here's a screen grab of the interface that you're looking at. If you see on the right-hand side, there's a little purple button. If you click on that, that will be for the poll. The poll is already live, and I know we have people already answering the question. It looks like right now that we have more people that are interested in environmental advocate versus a farmer ag professional, which is kind of interesting. In previous webinars, most of them have been a little bit more geared towards the farmer versus environmental advocate. But yeah, this is good to get your guys' feedback. So we'll leave this poll open through the duration. And if you can go to the next slide for me. And so again, the question that we were asking was, which the following best describes you, a farmer or ag professional? Or are you coming more from an environmental advocate? Or are you coming from both perspectives? Okay, all right. I think we have an animation that we're gonna be looking at, and this is going to be, what is the soil food web? The animation is gonna run for about 6 minutes, and then if you've got questions that you think of during the video, go ahead and post it in that questions box. All right.
What is the soil food web? To understand the soil food web, let's start with the term food web. We all know about the food chain, the animal kingdom on top of which are us humans, right? Well, if we look a little closer, we can see that some members of the food chain don't just eat one thing. That goes for humans too. So the reality is more like a web than a chain. This is the food web. There happens to be a food web in the soil too. This is the living part of the soil made up of insects, earthworms, and much smaller microscopic creatures such as fungi and bacteria. Dr. Elaine Ingham has pioneered research into the microorganisms in the soil over the last 4 decades, and has worked with a team of research scientists to understand how they interact with each other and with plants. The soil food web can be thought of as the soil biome. Just as humans have a gut biome responsible for digesting our foods, so too the soil has a biome, which breaks down organic matter and releases nutrients in plant-available form. This is how nature has been feeding plants for billions of years. The major groups that make up the soil food web are bacteria, fungi, protozoa, and nematodes. When in balance, these different groups interact with each other and with plants to create abundant ecosystems such as the great forests of the world. Have you ever wondered how forests can be the most productive ecosystems in the world without the need for any fertilizers or pesticides? The answer lies in soil biology. With a healthy biome, the soil can provide plants with all the nutrients they need, and with a number of other benefits, such as protection from pests and diseases, protection from drought and from flooding. The soil food web is, essentially, nature's operating system. Unfortunately, we humans have disturbed the soil food web in almost all of the soils that we manage, causing it to become unbalanced. As a result, the plants we grow struggle. Plowing is the major cause of the problem, as it destroys the larger microorganisms, such as fungi and protozoa, leaving the soil food web out of balance. This results in a system breakdown. Nutrients are no longer made available to plants, and protection from diseases is compromised. Before the Industrial Revolution, humans would plow using oxen or a bull, which provided around 3 or 4 horsepower. Modern tractors can yield 400 horsepower or more. So far more damage is done to the soil biome by modern machinery. The use of chemicals has compounded the problem. The good news is that we can restore the soil food web to most soils within just a few months. This results in a number of benefits, both for farmers and for the environment. With a balanced soil food web in place, farmers need not use fertilizers at all. They don't need to use pesticides either, as nature's operating system protects plants from attack. Herbicides, used to kill weeds, are not required either, as weeds only thrive in conditions where the food web is out of balance. Restoring the soil food web means farmers save money on chemical inputs across the board. It also means that their yields increase dramatically. In some cases, farmers working with Dr. Elaine Ingham have seen yields increase by over 200%. This is because the soil food web provides plants access to a constant flow of nutrients from soil organic matter, and from the soil particles themselves. That's right, sand particles contain nutrients, and guess what? Fungi and bacteria can harvest those nutrients. They then make these available to the plant in a process that the plant actually controls. This means that plants get access to the type of nutrients they need precisely when they need them. That's how you maximize yields and optimize profits. For the environment, there is a whole host of benefits of having a balanced soil food web. Humanity is facing a number of existential threats. Let's take a look at how some of these are related to the soil. The most obvious one is soil erosion. The United Nations Food and Agriculture Organization has estimated that we only have around 60 years left before all the world's topsoil is depleted. Other estimates are as low as 30 years. The soil food web prevents soil erosion by both wind and water by building structure. Please watch the animation on soil structure for more information. Another existential threat we are facing is ecosystem collapse. The UN has recently stated that insect populations have been decimated by around 25% each decade for the last 30 years. That means that there are 57% less insects today than there were in 1989. Bird populations have declined by 1/3 in the last 15 years in parts of Europe. So how does the soil food web help? Well, the UN has identified the use of pesticides as a major cause in the decline of insect populations. Please watch the animation on pests and diseases to find out how nature's operating system protects plants against attack, eliminating the need for pesticides. Another threat to life on Earth is climate change. Fortunately, the soil is capable of holding tremendous amounts of carbon in the bodies of microorganisms, and some mega-organisms too. The biggest living organism in the world is not a whale, it's a fungus found in Oregon that is the size of 1,665 football fields. It is between 2,000 and 8,000 years old, and it is made mostly of carbon. By restoring the soil food web, we could put a stop to climate change. Please watch the animation on soil carbon sequestration for more details. At the Soil Food Web School, we train people like you to help farmers transition away from using chemicals to farming in harmony with nature by restoring the soil food web.
Okay. All right. As far as that offer, I think that was an old part of the video. So January is all well and gone, so don't worry about that. But let's get into some Q&A. I think there's some questions that definitely popped in relative to the video that we just watched. So the question is from Jay, and Jay asks, when starting from scratch, how do you introduce the basic microbial method? Who wants to take that one to start with?
I mean, you're going to need the microbes first, so not trying to say it's the most important, but
something that's near and dear to Keish and Casey's heart, compost. It is the primary tool that we use, yes.
And typically the first thing we're actually going to do with a client is to do an assessment of what is in their soil to begin with. We may discover that it's dirt. And if you've used any inorganic fertilizers or pesticides, you're probably dealing with dirt, which means we've got to bring back the beneficial bacteria. We've got to bring back the good guy fungi, protozoa, nematodes, microarthropods. So that's going to be our first thing that we're going to do, is figure out what's the most advantageous way to add those organisms back to your soil. Putting compost down. What if you have really bad compaction layers right at the surface? There's not much point in putting compost down on top of something that hasn't got any structure built. So we'll actually till that compost into the soil one last time, where, after that final tillage process, you could probably go sell your tractors and your tillage equipment. Maybe not your tractors. You want to build compost piles with your tractors, but you could sell your plowing equipment, because you'll probably never need to use those again. So we want to till that biology into the soil as deep as we can get it. So, it depends on your tillage equipment. Is it going to be, 6 inches? Is it going to be 24 inches? Is it going to be 36 inches? Whatever. Get that biology tilled into the ground. Yes, you slice and dice and crush some of your organisms as you do that kind of tillage. But it's better than having massively concrete-like structures, compacted soil underneath a layer of really good biology. We want to get that moved in as much as possible. so that now those organisms have that full depth of that soil to start to do their jobs. And through the growing season, those microorganisms will move deeper and deeper into your soil profile. So hopefully faster than your roots get down there to the compaction layer, the microorganisms are going to be building more structure. And that those organisms will keep ahead of your roots moving down so that you can get the oxygen moving into the soil, so you can get water infiltrating instead of backing up and causing your soil to go, well, your dirt to go anaerobic and killing all your good guy organisms and probably your plants at the same time. So first steps, we want to look at what is in your soil. We want to recommend and make certain that those organisms are in your compost, so you can have a source to add all of those organisms. And it's billions of species. Well, maybe not billions, but close. We'd like to have all of the diversity present in your compost, all the indigenous local species of bacteria and fungi, protozoa, nematodes, etc., in that compost. So you're inoculating your dirt so that those organisms come back. And then we want to monitor throughout the growing season, just as Renald was saying. We want to inoculate. We want to, and so was and so was Keisha and Casey. We were all saying that we want to monitor and see what happens. And it's kind of like when you look at colonization of anything. When these organisms arrive, the conditions are so bad that a lot of those organisms are going to die before things really start functioning and working again. So we've got to come back in maybe 2 weeks or 3 weeks or, how soon. And we'll figure that out by looking at what's going on using the microscopes. So we may have to apply a second application. Well, what's the best way to apply that application? What's the best way to get those organisms to survive and grow and keep the process of building the structure, building the homes for the microorganisms, building the airways and passageways that allow oxygen and water and the root systems to move down, so that we can be now monitoring over the next several weeks. And do we need to do another application so we can bring your soil back to life, so that by the time you're harvesting your plants, those plants have had a chance to be able to take up every nutrient those plants need and supply all their nutritional requirements. So the food that you're growing for yourself and your family or your animals has all the nutrients in it. So it's going to improve everybody's health that buys your produce. So just kind of that's how we start out. And I do like to make the case for having demonstrations, having places on your property where you can bring in your friends, where you can bring in people and let them walk through your garden, let them come out to your agricultural areas so they can see the improvement in the plant production. They can take their metal rods and push them down into the soil and see you have no compaction left. So lots of possibilities there.
Yeah, I'd say that it's always interesting that compost is a prime tool, and that's a lot of people. Compost has such a bad name or misunderstood in the industry because there's a lot of really bad compost that's made. We're making compost that's biologically complete, has indigenous microorganisms, and so getting something that's sourced local with those indigenous microorganisms is really important. And a question I always get from clients is, well, what about this bugs in a jug thing? Off the shelf, can I go buy these 6 species of bacteria or these 5 species of fungi and apply them, in my operation? Will it work? You may get some benefit. I'm not saying that you won't, but you're probably missing a massive amount of diversity that you're requiring, and they may not be local to your climate, and they may not do very well. And so I think finding local sources of good microbiology is really, really, really important to push the needle. Anybody else want to make a comment on that question before we move to the next one? Okay, all right.
I think that's good.
Next question was, let's see, was this one right here?
Did you have something you wanted to say, Miles? No? Okay.
No, I
Sorry.
was just saying that's good. Yeah. So.
Sure. And so this one is a question from Erica, and it's kind of specific. It says soil food web is different in each country and each area in a country. How does this course work in South Africa, for example? Can you be a consultant anywhere in the world after qualifying?
Definitely. We teach you the overarching principles. And since I have already worked in agriculture on every continent in the world except for Greenland, although, yeah, and we don't really have agriculture in Antarctica, but every continent where we grow plants, the overarching principles are the same. What you have to have that's local is the compost that will have all the local indigenous species. And we teach you how to assess those indigenous organisms. Do you have the massive diversity of the bacterial species and the fungi and the protozoa in them? But do you have that? If not, then how are you going to go find them in your bioregion and get that into your compost pile? So that's where you get back to Keisha's very worthwhile concern about the starting materials you have in your pile. You really do want to avoid things that have been sprayed with really toxic materials anytime in the recent past. You don't want to be putting in vegetative material that is going to kill all the good guy organisms in your compost pile, right?
It's true, and it's interesting because we get to in our Skype group that we have through the school, where people are always sharing images of microbes from all over the world, and although they are slightly different, the morphology of them is really similar. I often see samples from across the ocean that look just like the nematodes that are in our compost. So, as different as the communities may be in different locations, they are strikingly similar as well when you put them under the microscope.
For sure.
Yeah, I would add to that as well. It's funny because I've been fortunate enough. He's been fortunate enough to work in a lot of different places in the world, and you will actually see some of the morphology change a bit. Like the flagellates you'll see will like change their shape entirely, and it'll kind of like the scariest ones I've seen are out of Brazil. But the biggest change with working internationally in different climate zones is the crop cycle. So figure out how to integrate with these systems becomes really important, because if you're working in the tropics, you're working with typically perennial systems, so you don't have rest periods. It's a non-stop cycle. It's hard to get a cover plant into that system. How do you get that compost deep into the soil when it's growing year after year after year and you can't rip everything out, right? So it's more about how you integrate with these different cropping systems with the different restrictions that you have in terms of equipment that's available. In the United States, we tend to use a lot of larger equipment, and a lot of the places where we've worked, it's all done by hand. And so you have to be able to figure out how to adapt to these different scenarios and figure out the best way to create your product and find the right materials to do it, and then how to best implement that within the restrictions that you're working around.
Very important points. Thank you very much for that, because finding that communication with the client is really important, and you want to spend some time figuring out the local climate. It's like in some parts of Australia, you get 4 or 5 feet worth of rain every year, but the problem is it all comes in January. The rest of the year is dead dry. You don't get any rain at all. Now, how are you going to deal with that kind of problem? And so you find yourself putting in dams so that you can be releasing some of the water. You have to build your soil structures so every drop of dew landing in that area is going to be put into the soil and allowed to be held deep within that soil. So all of those, well, if you will, tricks that you have to learn when you go to another country. And, that's why it's great to have consultants who are working in all different parts of the world, because then there is somebody that is already close to you as a new consultant. There's somebody close to you, hopefully, that has a lot of that information already written down. They already have experienced those issues. So like Renald, you in Latvia, if we had some new consultant coming through, I definitely want to send them to you to work with you. People coming through that want really good compost, send them to Casey and Keisha. And Miles, you've worked in Brazil, Ecuador, those places in South America. Those new consultants ought to certainly make use of the fact that you have some basic understanding of how systems work in that part of the world. Save those new consultants some moments of, how do I deal with this? Because you've already dealt with it.
One thing I just also mentioned about indigenous microorganisms and some of the practices is, if you can, try to work with farmers to do on-site composting. It's a great way. A lot of farmers have leftover crop residue, and sometimes it's a waste material that they are paying to get rid of. If you have the opportunity to try to get them to make their own compost. Now, some farmers are like, that's an activity I don't want to tackle. I'd rather try to source it. Other farmers are like, yeah, it makes economical sense. Let's set up an operation and do it. So it's another good way to get those indigenous microorganisms, as local as you can possibly get. It's coming off their fields, going right into compost, and going right back out into their fields. So, okay. Let's take a question from Marcy, and the question is, how long does it typically take for a soil to go from poor to high quality? So we kind of already answered that question. But there's an interesting second follow-up to this, which is it possible to plant something so that the soil keeps its quality without any human intervention having to benefit it? Who wants to take that question?
I find that when I'm first starting to go through the transition period, being present in the process to pay attention, for me, is the most important part. We often want to automate all the systems so it's very hands-off, and I do find that quite appealing, but I've never actually gotten it to work. I've got to check the moisture levels. I've got to use the microscope. And often there's multiple applications that are necessary, especially if you're starting in the wrong time of year. Like I started a garden in the spring in California, and I've had to apply extract 5 or 6 times this year to get everything to really grow vigorously without having to add a little bit of food into the system. So I'm curious to hear what everybody else says. If you have an automated way, I want to know.
I think it comes down to a lot of the management practices. So a lot of the means of harvesting and other ways of managing their crops are going to cause some amount of harm. So in some operations, it's going to be it's a perpetual thing, just like what they're already doing. They're having to manage their crops in a way. But I have a food forest here in my homestead. I don't need to apply anything to that food forest. That thing, I barely do any disturbance to it. When I go in and harvest, maybe do a little bit of pruning, but I'm really not interrupting that ecosystem. And it could fly on its own. I'm pretty sure I could leave it. If I left and came back 10 years from now, that food forest would probably still be rocking and rolling. So I think it comes down to how much harm does somebody apply, and then how much do you need to mitigate that harm. And a lot of it just comes down to the management practices that you have. Anybody else want to add?
I would say the same. Like you're talking about more of like an agroforestry system at that point. If you want to just walk away from it and leave it, I mean, you can walk away from the field and let whatever grows grow, and you don't have to touch it. But if you want food, you might have to have a little bit of management in there, especially if you're talking about monocrop settings. Nature doesn't do that. Nature doesn't just monocrop. So you're going to have to do something because it's not really the most natural way to farm. If you have a food forest or if you have an agroforestry system in place, you can kind of let that do its own thing for the most part. But that's kind of a different ball of wax as compared to working within a conventional farming system.
Sure.
I'm curious though, with your agroforestry system, Brian, wasn't there quite a bit of input in the beginning when you started?
Oh, for sure. Yeah. It was intensive to set up that food forest system. getting all the plantings right, doing all the tea sprays, doing all of the extracts, making sure that the biology gets set right. But at some point, that system is now kind of gone on autopilot. The microbiology is set for that food forest very well. The only thing I have to add to that system is moisture. I live in California. We have very hot, dry summers, and some of the plants that are in there just require more moisture. So I'm adding moisture into the system. But you're right. Getting there is work. Once I got there, now it's not a lot of work. How's that?
You should be growing olives.
Yeah, exactly. I should.
Renald, do you have any comments on this?
Yeah, I would just go along with what Miles said, because I have mostly a conventional experience, and disturbance, as we learn in the foundation course, is a part of what happens on planet Earth, right? And so we disturb. As Miles said, we want food, we have to disturb a little bit. However, I look at it through the perspective of rotation, which means what crop you're growing, what undercrop would you put that under your cash crops, and then what cover crop would you put after, etc., as a continuum of biology growing, which is supported by soil microbiology. So that's what I tell myself. I would wish to find a system, as Keisha says, that just go alone and then produce a lot of food and and everyone's happy, dancing, celebrating. No, you need some work a little bit. Yeah, that's my take.
Sure. I think it's much more possible to have a self-running system when it's a perennial plant, because you're not dealing with having to plant. Annual plants, you've got to get the seed in there. You're going to have to get the start in there. So you have to disturb to some extent. How do you minimize that? My view is we're going to be building up these beds where ultimately come springtime, hold on, I'll finish this real quick. Because I know the background noise just started, sorry. So in that annual system, we want to put in the row where we place the seed down on the bottom, put a extract down in front of the seed so that the biology is correct in that soil to grow the plants. But from that point on, we should have everything in the soil that we don't year after year after year keep building up those same sets of microorganisms. So in annual systems, we want to minimize the disturbance as much as possible, but we're going to have to have some disturbance year after year. But perennial systems, we should be able to set those up so they basically you are going to check the soil in the springtime, make sure everything's a-okay, no little surprises with respect to diseases or something, and then you let that system go. With the annual system, you're going to have to do a little bit of work in the springtime early on, and then once you make sure that everything's where it should be in the root systems of the crop, now you get to go fishing for the rest of the summer.
I have myself on mute. I've got dogs barking in the background. So actually, we're going to stop Q&A here. We're going to move on to our next animation, which is around weed suppression. So Alex, if you want to go ahead and just tee up that video and kick it off.
How does the soil food web suppress weeds? Weeds are a specific group of plants that grow really quickly and then immediately produce seeds. They have very short life cycles when compared to other plants. Like all plants, weeds need a lot of nitrogen in order to grow, but unlike most other plants, weeds thrive on a particular form of nitrogen called nitrates. Most other plants require some nitrates too, but they need more of a different form of nitrogen called ammonium. In a natural soil, where no fertilizers have been added, nitrogen is readily available as ammonia. Some of this is converted to nitrates by a particular group of bacteria, known as nitrifying bacteria. Scientists have discovered that nitrifying bacteria can only operate in a pH environment of 7 or above. With a balanced soil food web in place, soil pH can be prevented from reaching 7 by beneficial fungi that produce acidic compounds. And so nitrifying bacteria are prevented from converting the ammonium to nitrate. So now, ammonium is the predominant form of nitrogen available in this part of the soil. That means that weeds don't get their favorite food, and so their numbers are kept under control, making way for other plants to grow. Here's a real-world photo where you can see the difference in weed growth after just one application of soil food web biology. You can clearly see the difference. For farmers, the benefits include reduced costs and increased profits, as they no longer need to spray weed killers. For the environment, this means less toxic chemicals are being used. For humans, it means safer food. If you want to free yourself from weeds, then sign up for the foundation courses today.
Okay, so as we're waiting for some questions to come in around weed suppression, let's go ahead and take a question that was posted in here previously. This question was from Vince, and Vince asks, is it worth it to grow your own products to make the compost if you can't get it for free? So Keisha and Casey, you guys probably have a really good answer for this because you guys grow some of your own products.
Yeah, for sure. The space that we rent around our composting lot is 15 acres of pasture. So we cut and bale and treat all of that acreage. And honestly, when we have that material to use in our compost piles, they always come out the best. But unfortunately, I mean, a lot of it was damaged in the fire, so we don't get as much from it as we need for the year. So we end up buying a lot of that material. So yeah, sourcing materials is always one of the hardest things for sure, especially if you're trying to be super picky, because you can have random people drop off random stuff, but at the, you have no idea what's on that material. And,
right.
Even sometimes we go to the store and buy organic. They say it's organic, but it's not been certified, right? That's the line you'll hear often. And sometimes that stuff will ruin a pile and you end up with, 100 yards of compost that just never came up to temperature. And the bacteria fungi populations are just not there. So we end up having to use that material again to recompost in a whole nother pile. So
yeah, and also, so the idea when we first started, we thought that was our idea, right? Was we're just gonna work. We have this huge piece of property that we're working with this community. We'll just gather all of our own materials from the land, and once you get a few days of work in on a wood chipper and dragging limbs through a forest and just cutting everything, baling everything yourself, raising animals for the manure, you effectively have 7 different businesses and you're only getting paid for one of them. So we found it to be it's a beautiful dream. And if you're doing a small hand turn pile, absolutely take all the materials from your own land. People with farms, with landscaping companies, those are the guys that are set up already with tons of extra material. So just a warning, if you were to gather all your own materials at the scale we are, your compost would probably cost around $2,500 a yard. And we've actually run the numbers on that multiple times. So to keep the value reasonable, I find that paying people once you put a value to an organic material, right? We pay for all of our manure, and that gives them a reason to separate manure out. Say a horse gets sick and needs antibiotics or needs anti-parasites, right? There's a amount of money they're making every time they get rid of their waste to us. They would pay before to get rid of it. Now we pay them for it. So they're more likely to work with us and be honest when they're working with us. So developing these relationships long-term with your people, it's really important. And honestly too, you can only get free material from people for so long until they realize you're making money off of it and they're not excited. You don't want your manure producer to get mad at you. I promise, I've been through it. So offer them a little bit of something for their extra work to provide you with something really useful for your product. In our experience, that's just the best way, is to make it good for everybody. So everyone wins.
Yeah. And I think farmers are in particular position, if they do have a lot of crop residue, yeah, they may have the starting blocks and they may only have to bring in a few things. I mean, and some people take it to the extreme. I think Shane, if I'm remembering correctly, he's one of our soul food consultants in Africa that does a lot of banana and plus I think there's like 4 or 5 other crops. He's dedicated some land where he grows a lot of material that he's going to, as green material, he wants to use in his compost pile. But he's already got all the equipment. He's already got the systems put in place to be able to do that kind of stuff. So for him, it was an easy step forward to make that. But yeah, I think there's a lot of choices you can make to either buy or grow.
I've worked with a lot of dairy farms, especially in Australia, for example, down around Melbourne way. And they make all of their starting materials on the farm. They've dairy herd, so there's the manure. They have grass bales that they cut the year previous that they didn't have to use to feed the animals, or they've got weeds on the roadside. It's easy for them to collect all those materials. They have chippers because they've got their woodlots. They can pull the material out, and it's not that difficult. But and you're not in those kinds of conditions. You don't have a dairy farm that you are running. Yeah, then you have to search for good starting materials, and it's definitely worth it to pay somebody for maintaining the flow of top-notch material.
Exactly. All right. Any other comments from folks? Okay, let's go to another question. This question is from Liz, and Liz asked this question. A participant asked a question that I have also heard stated by Florida Extension. We are in Florida, where every farmer is told inputs are required for outputs. I've personally been told by Ag Extension people that there is no way to make soil on sand. Is this possible here? Please elaborate. All right, who wants to take that one?
I mean, the USDA publishes a Lynn's biology primer that talks, just precisely about how nutrient cycling works. So it's interesting that the extension offices don't agree about soil microbiology and its function in the soil. That seems awkward to me.
It kind of takes me back to when I was starting my work at Colorado State University, being told that soil organisms aren't important. Beg to differ. Go ahead, Miles.
Yeah, I was just going to say, in my opinion, nutrition isn't something you can necessarily entirely shortcut, right? Like your plant needs nutrition. The question is just where is that coming from? So if you're talking about synthetic inputs and just layering that into the landscape repeatedly in terms of inputs to make something grow, you're probably going to end up overdoing it. 80% of that ends up in the watershed anyway. So if you can build out the biological ecosystem to handle that and to produce some of those nutrients from your landscape, you're going to be able to kind of transition out of that type of intensive input system. But you definitely need to have the prerequisite organic matter set up, right? If you don't have enough organic matter in that system, you're not going to have a whole lot to pull off of. So you want to make sure you have the practices in place to be able to build up that organic matter bank in order to have a system that's carbon positive year after year, where you're able to feed the plants that you're growing on that lot. And so, I've worked in Peru in deserts and basically just 95% sand lots. And we're putting inputs in there, but it's compost-based inputs, it's organic inputs. And we're able to get really good yields out of that and build organic matter when we're using cover plants, associative cover plants, helping to build up that organic matter bank, leveraging leguminous plants for nitrogen fixation, and that helps to supply the nutrition that's required for these plants to grow.
Perhaps the people that you were talking to that's what they're talking about is damaged soils, right? I mean, look at the forest, it grows seemingly by magic, I guess.
Where are they getting their nutrients from?
Fertilizer fairies. Haven't you heard the fertilizer fairies?
Fertilizer fairies. Yep. Where, you think about Florida, it's just a big sandbar, really, basically. And it just hasn't managed to get all of the organic matter incorporated into that sand. Given enough time, it will. And we've taken fields in croplands and get the soil report from it on what's the texture in this soil, and All it is sand. There's no silt to speak of. There's no clay to speak of. And that water just whoosh right through, trying to keep that soil. And it's not really soil, it's dirt. You're trying to keep that soil watered. It's just about impossible. So we've had those sorts of situations of working with farmers in various parts of the world where they're trying to grow on basically pure sand. What's the percent organic matter? Less than 0.1%. So how could you ever build structure in that soil? That's where we've got to get in there and get a goodly amount of compost on there. We have to have understory plants. We've got to have that ground cover because we need the constant inputs of foods into that soil so that the microorganisms are always performing these jobs. They are getting the foods to keep them alive. And then your crop plant goes in and it's just kind of icing on the cake. And within the course of one growing season, we can typically take soil from less than 0.1% organic matter and increase it to over 3% organic matter. And so, here come the experts back to the field at the end of the growing season, and they look at that soil and they go, what did you do with the sand that was there? Because this is not a sandy soil. You have something now that looks like a loam. Well, send a sample in, get the report on the sand, silt, and clay. It's still 100% sand. There is no other mineral material in that soil. But we're above 3% organic matter. And that makes all the difference because now the organisms have something to eat. There's something for those bacteria and fungi to do that decomposition process. And now there's bacteria and fungi for the protozoa and the nematodes and the microarthropods and the earthworms to eat. So we've got to put the right biology back into the soil.
Yeah, and there's a following question. Well, I just one point here. A following question. It was around the sand. This was a sand question, but the same question around. Well, I have all clay. Can I grow anything in all clay soils? And I think the same principle applies. Sorry, Miles, I cut you off.
No, that's totally right. I was just going to say, if you're starting from something that's in desecrated land, I guess they're not incorrect in saying you need inputs, right? You need to be able to plant something there to put in compost in that land and bring it to a place where it's going to be sustainable. It's the same reason we cut down forests to grow on that land, because it's got so much banked up organic matter that you can just leverage that. And that's what people do. They cut down a forest, they plant it, they get great yields for 5-10 years, and then it's destroyed and they're back to scratch. And that's because they're not taking care of that ecosystem. They're leveraging it for maximum yield year after year. And then you're left with nothing sustainable. But yeah, it's the same with clay.
Yeah. They're an extraction system versus a regenerative system. Yeah.
Yeah, exactly. Yeah. And it's the same with clay. You end up with a system with too much clay in that system. You're going to end up with poor flocculation status. Typically, you dry out, you crack. You want to get enough organic matter in there to fill those spaces so that you can hold the moisture. You can prevent that type of cracking and just structure collapse that you run into. So yeah, it goes both ways. Organic matter is that fun middle ground that just helps no matter what you have going on for the most part.
Mm-hmm. And it always bothers me when you get some soil person that says, if you've got more than 5% organic matter, you're in danger of what? Growing too much crop?
Exactly.
It does have to be good compost. It can't be putrid organic matter, which is unfortunately what most of the waste reduction systems in the United States make. It's not compost. It's reduced waste. We've got to make certain that we're getting everybody aware that they have to have biologically complete compost. So that they're getting the biology that they need back into that soil. And that's what builds everything. That's what's going to allow their plants to reach their genetic potential.
Yeah, it's always funny when you get that, like you said, about 5%, you're in danger. Well, really, who's in danger? I think it's the fertilizer salesman that's in danger, not necessarily your crop.
I was going to say, Brian.
It's all about perspective in that sense. Yep. All right, let's go ahead and jump to another question here. I was just pulling one up here. Okay, this one's from Andrew. Andrew says, how would you manage a consulting for a farmer where his neighbor is still using chemicals and it's drifting into your client's crop/land? This is a problem for sure. Anybody want to tackle this one?
Brian, isn't it your current situation?
I have one of these, or a couple of them actually. Yeah, it's tough. It's hard for one neighbor to tell another neighbor, you got to stop your practices. I mean, there's always, something legal, litigious, I'm sure that can be done, but that's really hard to prove sometimes. I've advised some of my clients, put in a hedgerow, put in something that's going to be tall and a blocker and a species that can tolerate, some of that damage and just absorb a lot of that spray residue coming into place. It's a little bit of an extra cost for the client, but it's also some peace of mind too. And that's kind of the best way I advise, is just like put some kind of barrier, usually probably a living barrier in between yourself and your neighbor's cropland. And if you have the ability, talk to your farmer, talk to your, have your farmer talk to your neighbor and say, hey, look, what you're doing is harming our systems, and they may be more mindful about spraying when it's not so windy, or the wind direction's in a different direction and things like that. And what I really hope for, like one of my clients' properties, is that once his vineyard starts really producing and not having to use all those chemical inputs and the pesticides and herbicides, all that kind of stuff, that the neighbor will look at that and go, maybe I need to do something a little bit different and convert their practices. So I think there's always opportunity for that as well.
We were just in an interesting situation where somebody was using the hedgerow as the glyphosate block. And their whole property was just gorgeous. And then this one hedgerow is just, you can tell it's just been mashed on by glyphosate. And it really is an eyesore for the entire property.
Yeah.
You can just see the line of where the glyphosate stops. And it's beyond that.
It did its job. It was in the sacrifice zone, right? Where it's like, all right, you're standing tall there, trooper, but so sorry for you. Anybody else want to make a comment to that? All right, we got another question from Duncan, and this one is specifically around, what is the effect of glyphosate on the soil food web? Does it have impact? Anybody want to take that one on?
Beyond a doubt, it has an impact. Go read the papers published by Don Huber, and that just tells the final story. Roundup does the exchangeable nutrient thing, where it's going to grab on all of the soluble inorganic nutrients in your soil and bind them up so your plant can't use them. So right there's a big problem. And then glyphosate also is quite toxic to fungi and a lot of different species of bacteria, not all bacteria. So, it's not a 100% loss. It's a 50% loss of bacteria, but still it's mostly the good guys that are most affected by the glyphosate. Certainly any protozoa that were there, most of your good guy nematodes are going to be gone. So tell me, how can your plant grow if it's depending on normally or naturally cycled nutrients, on normal retention of nutrients in the soil, the disease suppression, all of those things, soil structure, holding on to water, all of those things that we talk about in the 7 overarching principles of what biology does for you. So glyphosate is a really scary proposition. Could we have some studies, way too expensive, way too much,
Exactly. Turning the blind eye, I think, is more the appropriate scenario. Yeah.
Under
but glyphosate
table.
Does. Exactly. Yeah.
Mm-hmm.
Glyphosate is harmful, and there's a lot of farmers who use it. It's a tool that they have used for quite some time frame, and sometimes it's very hard to wean them off of that tool. But it's important to try to remove those things out of your growing systems for sure.
Because as soon as you can get the fungi back into your soil and get them growing, then now we've got the ammonium present in the soil, and most weeds cannot germinate and they do not grow well once ammonium becomes a significant part of the nitrogen pool within that soil. You don't have to get rid of, you don't want to get rid of nitrate completely, especially if you're growing annual plants. But you've got to get it that little bit of distance down the successional system. So you're not growing weeds anymore. And, you know, if you didn't have to worry about weeds, you would not be out there tilling your soil every week or two to, you know, mix those weeds back into the soil and prevent them from producing all those billions of seeds that they like to produce.
And there's usually a readily available seed bank of all those weed seeds in that
Oh,
soil
yeah.
profile.
Yeah.
Yeah. And every
So
time you till, you just put them right back at the top. All right, ready to go. Okay, let's take one more question and then we'll go ahead and close. So we got another 4 minutes on this question. And this question is from Weston, and he asks, can good soil structure and biology increase the resilience of pastures for grass-fed cattle operations? Should be an easy answer for us here. Anybody want to take it?
Yeah, that's what we did our final project on.
Yes, yes, and yes.
When we got to the land that we're composting on, our idea was to grow grass, you know, for our compost, and there was no grass growing. The sheep had just eaten everything, like you saw in our little picture in the beginning, and really light application because we weren't going for minimums of biology in the soil. We were just going for getting some plants to grow in the system so we could compost with them. And, you know, almost 2 weeks after our first application, all of those bare spots filled in, and we see a lot less runoff on the pasture. It's a lot more able to hold water. We have to water way less now. And every year our grasses get bigger and bigger and bigger, barring the fire.
Yeah, well.
Grasses are pretty simple to work on. Grasses respond really well to biological treatments.
Yeah. I have a plot of land where I will grow some vegetable crop and so forth in that area, but a lot of times I leave it fallow. And when the grasses do grow in, the grasses are easily 2 times the size of the untreated areas around me. And so you just know that the soil biology is functioning very well in that plot of land where I put compost extracts and I plant with some compost and do some other things like that. But when it goes fallow and those grasses grow, yeah, it is insane. And like you said, the whole water retention aspect of it too, which is great because you're building structure and you can hold a lot more moisture in those fields.
It's
always want to make a comment? Yeah,
always fun when you have, especially like when we start doing demonstration plots, and half of the field is treated with biology and the other half is not. And then you put some cattle, some dairy herd into that pasture. Where do they all go to? Yeah, right over there to the biologically treated grass material because they can taste the difference. That is so much better tasting. And then eventually they'll get around to the other side of the field once they've pretty well taken care of this side. So it's something that even your animals can taste the difference.
Yep. Great. Any other final comments on that before we go and close out the webinar? Okay, Alex, if you can pop up our last slide. Just want to remind everybody about the current promotion that we have. And remember that there is a coupon. So if you click on your screen, the lower box, there was, I think, 50 coupons for this particular round. So get them all in a hat.
I'm not seeing the final screen.
I don't see the final slide yet either.
Alex.
He's probably furiously getting it shared back out. So what we'll do is, as we go through our closing, we'll just leave that screen up there. It gives you some instructions about how to, what the code is and how much money you save and so forth. So at this point, while Alex is getting that slide up there, I like to just go and give some thanks. Thanks to everybody behind the scenes. You guys haven't seen them, but they've been helping us keep everything on track. All of the communications and the promotions going out, and helping us select questions for the panelists to use. So thank you for everybody running the operation behind the scenes. Also, I thank all the panelists. Thank you for taking the time to share your knowledge and your stories, and helping folks understand what we do and that. And Elaine, thank you obviously so much for all of the the knowledge you've imparted, and you're very generous with the sharing that information with all of us, and just being a mentor to all of us as we have stood up our businesses. So thank you very much.
Thank you, and thank you guys for coming today and talking about all this wonderful stuff for this time period. So thank you all for helping.
Exactly. Okay. All right. We're going to go ahead and close this webinar, and hope to see some of you in the classes, on the forums, and eventually become consultants, be our colleagues out there in the field. So, all right. Thank you all. And panelists, if you want to just go ahead and stay in the Zoom chat.